Hello, my dear students. Very good morning to all of you. I welcome you all to this online lecture. So, in the last lecture, we studied the manufacture of Portland cement, in which the manufacture of Portland cement involves various steps, that is, raw materials, proportioning of the raw materials, preparation of kiln feed, beneficiation by flotation method, burning operation, and treatment of clinkers. In the previous lecture, we studied the raw materials, proportioning of the raw materials, and preparation of kiln feed. These three steps were we studied in the last lecture. Raw materials already we known that is calcareous material, that is calcium containing, that is rich in the calcium material, and argillaceous material, that is rich in silica and gypsum. So these are the three important raw materials for the manufacture of Portland cement. Second, proportioning of the raw materials. According to the type of a Portland cement, the different proportioning can be takes place, where the merits, as well as we can say the importance of proportioning of the raw materials, whether it is lime is there, or the silica is there, or the alumina is there, or the ferrite is there, according to the requirement of the cement, the proportioning can be takes place. And preparation of kiln feed, where we studied the preparation, that is raw material for sending towards the kiln, that is the feeding, which is a pre material which is prepared by using the dry process and the wet process, where from the materials obtained from the dry process, that is raw meal, and the material which is after grinding and the mixing obtained from the wet process, that is called as the raw slurry. This much of things we studied in the yesterday's lecture. Today we are going to see beneficiation by flotation, burning operation, and treatment of the clinkers. Now see, what is meant by beneficiation by flotation method? This is nothing but a physical treatment of which prepare the feed for the rotary kiln. Here we can say this also called as the dressing of the ore, where it is a common practice to upgrade the raw materials in the desired constituent. One such a method commonly used in the cement industry is known as the flotation process, which involves separation and removal of unnecessary minerals constituents from the desirable raw material. This is very simple. It means nothing but the where the after proportioning of the raw materials, where the material obtained from the dry process and the wet process, that is raw meal or raw slurry, further it can be filtered, or certain unnecessary things or unnecessary mineral constituents which are removed by the help of beneficiation by flotation method, where the either fatty acids flotation cells, or anodic we can say anodic cells, or cationic flotation cells are employed. It means two different cells can be employed here. The fatty acid flotation cell contains oleic acid, soap, frothing agent like synthetic alcohol. The materials are ground to pass through the 100 mesh filter, where in case of the fatty acid flotation, the materials are passed through the 100 mesh filter. It is then added to the flotation cell. It means a certain unwanted fatty acids materials can be removed with the help of fatty acid flotation cell. Second is cationic flotation cell. It containing cationic reagent like hydrochloride of fluoramine, where this reagent, when added to the slurry of ground raw material, the silicates of aluminium and magnesium combine with and float on the surface. This is very important. By adding this hydrochloride of fluoramine, where the things of the silicates of aluminium and the magnesium combine with it and floats on surface of the while the ferric oxide quartz get removed under the flow. It means this is nothing but the beneficiation by flotation method, where the unnecessary material they are easily separated, which are required, which are not required for the further feeding of the rotary kiln. So with this, there is a physical treatment of the raw materials can be done by using the beneficiation by flotation method. Further, once the beneficiation by flotation method is completed, the required raw materials which are moved toward the rotary kiln where the burning operation is takes place. This is a very important and significant procedure where in the formation of the cement, where in the formation of the cement, this is a significant operation, that is nothing but the burning operation. Where in this figure we can see here very clearly there is a certain cylindrical furnace is there, where we can see the accurately proportional finely grounded raw materials. Already we seen that the raw material which are properly proportionated and the groundly mixed properly and separated clearly, that is physical treatment was done. This much of all the raw material, now it is ready to feeding the into the kiln, that is rotary kiln for burning operation, where which is whether we can see the in the form of the raw meal from the dry powder, or uh, like we can say the slurry from the wet process is feed into long steel rotary kiln in which burning operation is carried out. Here we can see in the picture or the figure, there is a certain elongated cylindrical furnace is there. From the left hand side there is a waste heat is there, or settling chamber is there. If you observe carefully, the cylinder, that is which having the rotary cylinder, which is completely length of, we can see the for the wet process, here we can see the total cylindrical furnace which is made up of, according to the method which are obtaining, whether it is raw slurry or the raw meal, whenever the material obtained from the wet process, the kilns are 90 to 170 meters in the length and 2.5 to 6 meter diameter, because the material, that is slurry, which is in the wet condition, where in case of the dry process the kiln may be of a short of 50 meters long. Again, the diameter which is of 2.5 to 6 meters of the diameter, which are continuously revolved with the speed of half to 2 rotation per minute. That is, it means the total cylinder which continuously rotating with respect to half or to 2 rotation per minute. Here we can see there is one important thing is that this total cylinder which is inclined position, which is in the inclined position, where we can see from left to right, where the here drying zone is there, decomposition zone is there, and the centering zone is there, where the raw material which is feed from the top of the top zone, which is higher zone, that is drying zone, where the temperature, if you move if you see the temperature, it is at the lower side, which is very high. The burner we can see from the figure, and the left hand side raw material is feed, and from the right hand side, the cylindrical lower side of the cylindrical, the burner is kept, where the highest temperatures are toward the lower end of the kiln. If you observe carefully, from the left hand side there is a certain cylinder slightly it is increased, that is inclined. Why it is inclined? Because the raw materials are moving towards from left to right, means top to the lower side. In the lower side there is burner is there, where the highest temperature are towards the lower side of the kiln, because means the materials are whenever moving towards the burner, their temperature is increases. As the charge slowly moves down the rotary curl, it proceeds toward the hotter zone. Here we can clearly see that raw material at the top zone, that is the lower temperature, and the raw material at the bottom zone, that is towards the burner, that is a higher temperature. This we have to keep it to be remember. So it means as continuously rotary kiln which is in the rotation continuously, the rotation with rpm of half to 2 pm, the materials on feeding from top to, that is continuously moving towards the hotter zone, towards the lower end, towards the, that is burner side, where we can see the maximum temperature is about 1400 to 1600 degrees Celsius. It means that the lower end, which is higher temperature, that is how much, one, that is 1400 to 1600 degrees Celsius, which is at the lower end. But the heat from gases coming out from the upper end kiln is recovered by passing the gases through the heat of the boiler, or the heat is used to other gases to preheat of the raw materials, where you can continuously see from the left hand side the raw materials are feed, and the raw materials are continuously moving from left hand, that is from a lower end to the, that is lower temperature, towards the higher temperature, that is top end to the lower end, where the lower end is having the higher temperature, where the kiln is continuously rotating. That is the total kiln, which is divided into three sections. That is the top section, which is the drying zone, and middle section, which is the decomposition zone, and the lower end, that is which having the flame zone, which is the sintering zone. You can see here. Now, where the rotary kiln, that is clinker formation, which is divided into three zones, where it is, or we can see the rotary kiln charges slowly passes through different heat zones to reach the other end of the furnace. Means from top end to the lower end, where the top end temperature is low and the lower end with the temperature is very high towards the flame, the material is continuously moves with a rotation. So here we can see the rotary kiln, which is divided in three sections. The one is the drying zone or drying section, second is decomposition zone or calcinizing zone, and third one, which is the sintering zone, that is a lower temperature, which is known as the sintering zone. Where we can see in the drying zone, that is upper portion, it is also known as water evaporation zone. There is a drying zone is also called as the that is water evaporation zone. In this zone, water is driven out of the slurry by means of the hot gases. The temperature of this zone is about 750 degrees Celsius. This is very important. This is drying zone, means here water is removed, where the material is out of from the water, out of from the moisture, with where the temperature is 750 degrees Celsius. The free water from the slurry is driven off of 100 degrees Celsius at the 500 degrees Celsius, and above there is evaporation of combined water from clay. The further the ferric hydroxide is converted into the ferrite. Here we can see where the Al2O3 and two molecules of SiO2 with 2H2O. This is nothing but the raw material, where alumina, silica, and which contain the raw material, where the 450 degrees Celsius initially, which removes the water molecule. Further, this water molecule in the form of the vapor, where treated with the ferric hydroxide, combined with the we can say ferric, that is Fe, it forms ferric hydroxide. Further, this Fe, that is ferric hydroxide, is converted into ferrite, where we can see completely water molecule is removed. With this, in the drying zone, water is removed or free from the water can be takes place. The second zone, that is decomposition zone, that is middle portion of the kiln, which is known as the decomposition zone or calcinizing zone. Where in this zone, the temperature is rises up to 1000 degrees Celsius now. Where in the drying zone, temperature was 750 degrees Celsius, where in the decomposition zone, the temperature is of 1000 degrees Celsius. Here, the organic matter burns away and decomposition of limestone and the dolomite, that is magnesium carbonate, takes place. Where the higher temperature is there, it means that decomposition of calcium carbonate into the form of calcium oxide, carbon dioxide, which is removed, and magnesium carbonate, which is removes magnesium oxide. The above decarbonization process is endothermic. Chlorides and alkali salts are partially volcanized. A portion of sulfate is decomposed by liberating the SO3. It means where in the decomposition zone, the decomposition of the lime, decomposition of dolomite, it can be takes place in the decomposition zone, that is in the middle zone of the portion of the kiln. Now the last zone, this is very important, that is hottest zone or sintering zone, where this is called as the lower portion of the kiln. As we seen that from the top end there is a lower temperature, at the lower end, that is lower portion of the kiln, having the higher temperature, which is known as the sintering zone. It is also known as the cement forming zone. This is also called as the cement forming zone, where the clinker formation takes place. In this zone, temperature is rises up to 1400 degrees Celsius. Here about 20 to 30% of the material undergoes melting. It means all the materials which are decomposed, further they are combined. Here we can see the calcium oxide and the silica, or calcium oxide or the alumina, calcium oxide or the silica, or calcium oxide plus ferrite. All these are combined, where we can see dicalcium silicate or the tricalcium silicate or tricalcium aluminate. All these molecules are, they get combined and they get we can say with the help of higher temperature they get melts and they get combined. Melts reacts with the surrounding particles and sintering takes place. Here we can see all the materials melts and melts with the surrounding particles and sintering takes place where the lime reacts with clay to form calcium silicates and the aluminates. Sintering takes place in this zone and formed material, and the material can be formed is known as the clinker. Where the clinkers are nothing but clinkers are the round spherical formation of the material can be takes place. Where in the hottest zone or sintering zone, the formation of the clinker can be there. Where the further clinkers are treated with respect to according to the cooling and the further in the further process we can see the clinker or treatment of the clinker where the calcium oxide silica it forms dicalcium silicate and three molecules of calcium plus silica it forms tricalcium silicate. Calcium oxide plus aluminum it forms tricalcium aluminate or calcium oxide aluminum ferrite all are formed that is tetracalcium aluminum ferrite which is also nothing but the composition of the cement in the composition of the clinker. Due to the combustible and volatile products, about one third of the original weight of the dry mixture is lost in the burning process, where a complete sintering takes place of the raw materials. Means once the formation of the clinker is very important, that is nothing but the further these clinkers are to be treated. This is the last step of the cement formation, which is very important. That is treatment of clinker. What is now once the clinkers are formed in the sintering zone, where clinkers are nothing but a small round balls half to 3 by 4th inch size with greenish black or grey color discharged from the rotary kiln or rotary cooler. What are the clinkers? What is formation of it? Looks like a granules. The clinkers are looks like a granules or small round balls up to 3 by 4th of inch of size, which having the color of greenish black. You can see further these clinkers are rotary clinkers. They are the cooled first. First they are cooled. The rotary cooler is rotating a shell fitted with a flat plate which is lift and drop the clinkers to affect the cooling. Means first is that what we have to do it once the clinker forms are there, there is cooling should be there. The rate of cooling is controlled to avoid the complete crystallization of the clinker. This is very important. Means what? The gradual cooling can be takes place. Where the cooling should be not the sudden cooling. There is a gradual cooling. The rate of cooling is controlled to avoid the complete crystallization of the clinker melts because it's incomplete crystallization. Therefore, initially cooling this takes place of the clinkers, but the cooling should be in a rate of control, that is gradual cooling should be there. Second, addition of retarders. As the clinker passes to the grinding mill, it is mixed with proper amount of the retarders. What are the retarders? As we seen that is gypsum, where gypsum is nothing but act as a retarder, that is calcium sulfate plus 2 molecules of H2O, or plaster of Paris calcium sulfate plus half H2O. They are acts as a retarder, that is negative catalyst, that is slow down the time setting of the cement. Where what is the bigger role of the retarders? It controls the time setting of the cement. It also avoids the rapid setting of stiffening of the concrete. The addition of 1% of talc improves the grinding efficiency by 6%. With this means sometimes gypsum is added and talc is, that is powder talc is added for improving the, that is we can say efficiency as well as the time setting of the cement. And finally, once the grinding is takes place, means after cooling and the addition of the retarders, complete grinding means the once the clinker form in the spherical form, they are completely grinded in the powder form, and the containing gypsum additive finely grounded in a ball mill. The finely grounded cement is then passed through the air classifier where the cement is soils. Finally, storage and packing of the cement. Once the complete cooled and in the powder form, they are to be storage for the in the market. So with this, we can see here the complete manufacture of a Portland cement involves the different steps, that is raw material, proportioning of the raw materials, and further preparation of kiln feed, beneficiation by flotation method, burning operation, and the finally treatment of clinkers. So with this, I hope you all are understood the manufacture of formation of Portland cement. Okay, thank you for watching this video. Thank you so much.